course is about accessory dwelling units. So we're going to learn about those. We're also going to learn about JADUs, junior ADUs, and what some of the differences are. We're also going to understand really some of the energy implications and the energy compliance for ADUs, and also learn about new and existing ADUs as well. We're also going to go into kind of the solar needs, HVAC, domestic hot water, some of those requirements, that sort of thing. Okay, and throughout these slides, we're going to get little pictures of pretty little ADUs that we have found. This one particularly nice. So we're going to really just talk about why we need them, and we're going to then dive into what they are and what they look like, because we got some nice slides there. Code requirements. And we'll bring it up with
sorry about that, Russ.
It's all right.
Slide there.
And then finish with all electric ADUs, because that's popular. Okay, so why do we need them? I think one of the big things is the state as a whole, and the state government has realized that there's a big housing crisis. And ADUs are one approach to trying to solve this housing crisis. There's going to be a lot of different solutions, and this is hopefully going to be one of them. And skyrocketing housing costs are part of that. This is an ADU is an easy way to have a little bit of 1-2 people can live in these, and they're a little small for in some cases, but they can actually be quite big, as we'll learn later. Hopefully ADUs will help address this shortage of affordable housing. We're going to see if that really does that in the future. We're hoping it will be. And it also expands the limited housing, zoning for residential areas. So there's a lot of single-family zoned communities, and it can add a little density with ADUs. And then the public has wanted to have this. There's been a significant demand. Certainly, how many people are on this webinar is an indication of that. Homeowners are realizing that they can either build one in their backyard and move into it, or they can have it rented out. They can have family members move into it, and so it offers a lot of flexibility, and that's something we'll go into later as well. Okay, next slide. So what is the accessory dwelling unit? So it can be, it has to be a complete living facility. So it has to have a kitchen that you can cook in, a bathroom with a shower, some way to bathe, a toilet, that sort of thing. It's the self-contained building. It can be either detached, which is a standalone building, or it can be attached and it can be connected to the main house. And you can also build it out as, if you have a garage, it could be converted. So any existing space, I think in this handbook here on the right, they talk about a 3,000 square foot barn that could be converted into an ADU, given the space. So there's a lot of flexibility between, a garage like I have, which is a 1940s garage, which barely fits a car now, but that could be converted with all the proper sanitation. Okay, next slide. Okay, so here has San Luis Obispo has an Appendix Q for tiny houses, and here's the plan for it. And they've wanted to promote this, and this is one of the approaches. this particular one is 320 square feet. So according to this, the requirements, it can only be up to 400 square feet. Lofts are included, and you can have a ladder. So there's a little bit more flexibility on this, and of course you need egress window access.
Oh, Russ, I think we should mention too that each jurisdiction has slightly different, versions or adoptions or caveats. So be sure to check with your local jurisdiction, but this is just an example I know of, in San Luis Obispo.
Perfect. Thank you, Jennifer. Okay, next slide. So we're going to get into a few pictures, show, kind of what, is out there, different examples of ADUs. This one is a new construction. It's in the backyard. They're very interested in roofs here, and so there's a lot of roofs. But what we wanted to point out is the exhaust fan, the kitchen range hood. This is something that's required, and it is here in this unit. So even these small ADUs do require ventilation, and this is showing that right there. Okay, next slide. So this is an existing garage conversion. So this was a garage, and the photo on the top right kind of shows where the driveway was, and they did some little bit of adjustments there, and then they have in the front, instead of the probably the roll-up doors, they have doors that are actually opening into these very large doors. And what's interesting about this is they have some interesting features here. They've circled the mini split, so it looks like this just has a mini split, which is providing heating and cooling to this unit. There's a table kind of in the front there, and that actually rolls out of the way, and you can see it on the bottom right. So there's some really interesting design features that, given these small spaces, people are utilizing, and they're being very creative, which I think is excellent. Okay, and then there's the existing structure. So this, I believe, was a garage, or might have been a workshop, or both at one point. And this is another way of converting, just taking an existing structure and providing a bathroom and a shower, and then a kitchen. This has a full kitchen. Okay, let's see. And then this is another option. So this is a new detached garage below, and then above there's an ADU. There's a staircase right there on the right, and it's on the second floor. Okay, what else is next? So JADUs, or junior accessory dwellings, are a little different. They're basically, there's a lot of flexibility within it as well, but these are required to be 500 square feet or less, and they have to sit within the building, an existing building, and it has to be attached to the main residence. So if there was an extra room, let's say there was a master bedroom that they want to convert into a JADU, they could. It could be a garage, but it has to be connected to the existing single-family house. It also can be new construction. It could be all new construction, and so it can be part of that as well. So that can be planned from the very beginning. It has some different features. It can include a separate bathroom, but it also can share that bathroom. It can be shared, a bathroom can be shared with the existing house. and it may share central heating and cooling systems as well. But it needs to have a basic kitchen, a hot plate, a little sink as well. Let's see.
And entrance. So a person can get in and out of the junior ADU without going through the house, but you can go through the house also, right?
Yeah, so that offers that a little bit. So there's a lot of little features in this one.
Yeah.
Okay, next slide.
Okay, now, this is a fun slide, and this is where I take over. I'm going to do some really fun code stuff. For those of you who don't know me, I think the code's kind of fun, but you know, I know to each his own or her own or their own. One way to understand, I think, the energy code and ADUs, and the reason we're doing this, been asked to do this particular learning unit, is because we get a lot of similar questions about what is allowable and not allowable with an ADU and a junior ADU. And there does seem to be a little confusion about what part of the code applies to these accessory dwelling units. So kind of right off the bat, I just want to remind everybody that the energy code has sort of three ways that it looks at it. And then the world of the ADUs and the planning world and the way people just think about things is we use a different set of vocabulary and how we look at it. So there's mandatory measures through the energy code that every structure has to do, no matter what, even if it's a new construction or whether it's one of those conversions or additions that Russ talked about. You have mandatory measures. And then when we talk about building an ADU that is a standalone by itself construction, we would use a particular part of the energy code for new construction. And you would comply with all the envelope, ventilation, mechanical, heating, cooling systems, including what's new to the code is adding solar panels or PV system. So that's standalone. And then we have this other bucket, which has to deal with all the additions and alterations and conversions, whether it's attached or detached, and all that falls under the energy code that deals with additions. And there's a few things that we're going to hit on with those that come into play that have to do with some things you should know about the envelope, a little bit about the ventilation, mechanical heating and cooling, and the hot water. And then when we talk about those junior ADUs, which Russ just gave us an example of, if it's all new construction that's part of the house, well, that falls into the new construction part of the code. In other words, you can include a junior ADU in your brand new single family house. And that the whole package falls under new construction. Or you could it could fall under the additions part of the code with the garage conversion, or it could just be that you're changing a part of the existing house. And then you would use the alterations part of the code. And let me know if there's any questions on this stuff along the way. Use that chat. So I think the most easy way to look at the code for the new ADUs is new construction. So anytime you're building standalone, brand new construction, it's detached, you're going to comply with the new low-rise residential standards. And the reason I'm highlighting the PV solar panels are required in our diagram and in our list on the right is because as a code coach, that probably is one of our most common questions is I'm building an ADU. I already have a house there. Why do I need solar panels? Well, if it's brand new construction standalone, it's considered new construction under the energy code. but there's some exemptions that might apply to you. We'll get to that later. The other thing to know is that there are conversions and additions that you can do that we saw examples of that are considered additions under the energy code. So in other words, if you just have a straight up I just think of it as a typical addition. So your existing residence, you build a new ADU, it's attached to it. That's new to you, but as far as the code's concerned, it's an addition. And then you might take an existing garage, which is already connected to the house. And if you convert that to an ADU, that's also considered an addition, even though it's within the existing structure. And there are certain rules that apply to that specifically. And then if you have a detached accessory, a shop, a detached garage, again, you can convert it. And it also is considered an addition under the code. And what that looks like highlights some of the sections under the code. Now, see, I like to point out what part of the code some of this is coming from because I'm a code person. And for those of you on the call who have to read the code yourselves, you can go to that section 150.2 additions and read through it. And some of the highlights is that there's something called a wall extension exemption in the envelope. We're going to talk about that in a moment. There's some ventilation requirements that are specifically called out for new dwelling units. We'll hit on that. And then what's just kind of not explicitly put in that part of the code, but just part of the energy code and the building code, mechanical code in general, is that ADUs, dwelling units, separate dwelling units aren't allowed to share their air back and forth. They can't share return air when you have a dwelling unit. So if you're essentially taking existing residence and converting it into a duplex, really. So it's two individual standalone units, each with their own cooking, each with their own sanitation, each with their own entrances. You're not allowed to share the air between those. So we'll talk a little bit about what options are available for the ADU on the mechanical, and there's some options too for providing hot water for everything. Now, when it comes to the wall extensions or exemptions on these additions for ADUs, so the addition is new to you or your client, and you're aligning an outside wall with this new ADU, that wall alignment is called a wall extension under the code. And under the code, that wall, it can be a skinny wall in the sense that if you have a 2x4 wall in your existing residence, you only have to build a 2x4 wall with an R15 insulation in that wall extension, which is represented by the thick line at the top of the diagram. But the other two walls on your new ADU, they're considered new walls. So you would have to comply with the prescriptive components or use the performance method energy modeling. So the code references you to table 150.1A or B. You're like, okay, so for those of you who have to deal with the code a lot, you go, okay, that seems simple enough. I'm going to go look up the table. And then you look up the table and you figure out you're in climate zone 5 or 6 on the Central Coast, maybe climate zone 4 where I live. You enter the table at the top, your climate zone. You come down and you say, okay, I need an R30 insulation with a radiant barrier, check. Okay, next. For a framed wall, I need a U.048. Okay, sidebar, what the heck is a 0.048 wall assembly? And can also, for the milder climate zone 6 and 7, 0.065 wall assembly. What the heck? So now that part of the table, unfortunately, is not really explained out very much. So if you're new to the code, Or if you want to have like architects, if you need a cheat sheet in your back pocket, or even the plans examiners of what meets those requirements, I'll give you a little translation here. That for those new walls and all the new construction, if you're in climate zone 6 or 7, you would need an R15 in your cavity of that 2x4 wall, and you would need an R for continuous exterior insulation at a minimum. That would comply. The smaller the U factor number, the better. So once you get to a more heating and cooling demand climate, then you have to up the ante a little bit, which would now turn to a 2x6 wall filled with R21 insulation with an R5 continuous exterior insulation. Now, I'm going to point out that we don't have that many of our clients in our area follow the prescriptive method. This is a baseline, so a lot of times they'll ask us to do computer modeling to help mitigate away from this continuous exterior insulation. But as far as the way the code's written, having the continuous exterior insulation is your baseline. So practically speaking, what does that look like? For those of you on the call who are not familiar with the California Energy Commission blueprint publication, I want to point that out because they have a great issue where they've diagrammed out these wall extensions and new walls and help clarify what is required. So the diagram on the left, again, if your walls are lined up with each other, you would only have to fill that cavity with insulation in that new wall, even though it's new. But as soon as you join a new wall on your addition that's connected into existing walls, but they're not in alignment, like the diagram on the right, now you're back to the prescriptive requirement, which for a lot of climate zones would be an R21 2x6 wall with an R5 continuous. Now, when it comes to those existing garages or shops that got converted, they already have walls in place. So the code's trying to be flexible here to really not discourage the ADUs, but to encourage that people will build these ADUs and can take advantage of safe existing structures and converting them to habitable space. And when those existing walls are already in place and you do not remove the siding, you leave the siding, you leave the outside of the building intact, then all you have to do is come back and fill those 2x4 walls with R15 or fill those 2x6 walls with R21, and you don't have to add that continuous insulation. Now, if you take these existing structures for your ADU and you completely peel off all the layers and you're down to studs, then you're back to bringing it up to the prescriptive or a thermal energy model to try and trade off away from it. Now, the junior ADUs are a little bit similar when it comes to brand new construction or the conversion. So again, brand new construction. So if your junior ADU is just rolled right into the whole single family house as a brand new build, you're going to be under those new low-rise residential standards. And if your junior ADU is taking an existing enclosed garage that's less than 500 square feet and converting it, then you're going to follow along with all those previous slides for an addition attached conversion. And then kind of unique to the junior ADUs is getting that junior ADU, doing it as a remodel completely within the interior space of the existing residence that's already conditioned. Like, let's say you have a bonus room that you convert. Or like Russ pointed out, if you had an existing primary bedroom and bathroom, but then added some cooking facilities, any type of the alterations you make, say on those walls to get in that exterior exit or improve the windows and the natural light in that space to make it function as a junior ADU, then those walls and everything you do are going to follow just the alterations, which is even more forgiving in the sense that if you take out insulation to get that new door and window in, you just need to replace that insulation in the walls. And if they already are insulated with an R11, you can just insulate it again with an R11 or better. Okay, now when it comes to the indoor air quality part, for the ADUs, they have to have their own indoor air quality. They need to comply with that. And the way the code reads is it sends you, if you're not familiar with the code and you have to look this up for yourself as an architect, you read it and it's going to read like, ooh, you have mechanical ventilation airflow provided in accordance with sections, and then it sends you back to all these other sections as applicable. And the airflow rate has to be based on the condition floor of the new dwelling unit. Okay, translation. Basically, you're gonna follow ASHRAE 62.2, which means the same formula you've been using for natural ventilation for the ADU applies for the new construction. And you are allowed to use any type of exhaust only, like bath fan, supply only, or balanced ventilation if that ADU is detached, or if you're permitting it as another single family residence. Okay, but once these units are attached, or if they're sharing enough surface areas and they're part of a might be considered a multifamily, like now instead of a single family, you've got a duplex there, then you really want to prevent those attached units from sharing the air passively with each other. In other words, if you turn on an exhaust fan for both of them, and the exhaust fan is only running for one of the units, it's very easy to negatively like pressurize that unit potentially, and you would pull in air from the other unit, which could be cooking, other people's cooking and smells. It could be laundry detergent they're using that the other tenant's allergic to, or could be that someone is starting to smoke in one of the units and pull that smoke into the other unit. So short of doing boundary sealing and acceptance testing and HERS radar and blower door testing, our recommendation is just from the get-go, you use some simple balanced ventilation methods to meet the indoor air quality. And by balanced ventilation, I mean that the supply air comes from outside through one unit. It could be an inline fan like that Brown Newton system that's shown down at the bottom in the middle. It's an off-the-shelf product with a wall switch, so you can regulate it, especially if the outdoor air quality is poor from fires and you need to turn off the fresh air ventilation. You can turn that off. And you would have an exhaust fan just like you normally would see with a bathroom, and it would exhaust the air out. And this way, this unit and your adjoining unit would not adversely affect each other. The other way you can do it that includes some heat recovery, so that you're not just introducing really cold or really hot air, is, for example, the Panasonic brand makes an ERV that's easily installed. It fits up in the ceiling. What you see is just that surface plate, and it includes the ability within that unit to take in and exhaust the air through a heat exchanger, and you would use really simple, small 4-inch diameter ducts to the outside of the project. when it comes to the heating and cooling on our ADUs, we have some options on how to do it and how to accommodate that. Oh, before I go though, were there any questions? Do we have any hand raising or anything anyone is curious about on some of this stuff?
Yeah, and this is actually a good time, Jennifer. We have a question. Is a kitchen range hood required in an ADU?
Well, yes, in the sense that you have cooking facilities and you will need to have a way to make the air in that kitchen leave the kitchen. And it doesn't necessarily have to be a range hood. It's possible that you could use a fan, an inline fan that would do the same thing as a range hood. So if you're space constrained and you don't really, and it just doesn't seem practical to use a range hood, you can use an inline fan that does the same thing, but you have to have some way of exhausting the air.
Okay. And if you already have a bath fan for that, do you need a kitchen range hood?
Hey, you know, can I just, since I answered the question, let me just.
Yes, please, go ahead.
Quick. So just, you were pointing to the kitchen hood as required ventilation. So required ventilation, like a whole house fan, is required in an ADU for sure. But if I have an all electric range, I don't necessarily need that to be part of my ventilation system. If it's all electric, I'm not combusting anything. I could filter out, I could use one of the filtered hoods where it just spits it back in the room. But I don't need ventilation there, do I? Can I solve my whole house ventilation in the bathroom fan?
That's a good question. So we have this come up sometimes, and I've seen different jurisdictions interpret it differently. I know for our projects that are for LEED, for example, that are strictly complying with ASHRAE 62.2 and 62.1, which is what the California Energy Code has been more and more aligning itself precisely with it. Then there's a certain requirement for how much CFM is specifically taken, evacuated from the kitchen. And my experience is, even if you have electric or induction cooktop, there are times where people mess up when they're cooking and they do burn stuff. And there's also just a certain amount of odors and grease. So what I have seen as a solution is some folks using a recirc fan microwave unit, and then adjacent to that area, they put the inline fan so that they can evacuate that kitchen air out of the kitchen, but they've used that recirc inline for the filter. But it's really not meeting code if you only have that recirc fan, unless your ventilation exhaust is right there at the kitchen, but you're still going to have by code ventilation exhaust for the bathroom for humidity.
Thank you. That answered my question.
Okay. Now when it comes to heating and cooling the ADUs, I mean, by code, you can heat and cool your space with any fuel and any code compliant appliance you want to. But I think ADUs are a unique situation in that they're usually quite tight on space, and it oftentimes is not cost effective to bring in a fully ducted system for such a small space. And you may not share the return air with the primary dwelling through that heating and cooling system. So it does require separate separate air handlers, separate air systems. So what we see a lot is the installation of mini splits or split heating and cooling, where you have an outdoor unit providing both the heating and cooling capability in the form of a high efficiency heat pump. And then you run your condensate line and your line set from that unit with refrigerant. In this case, this is a raised floor, so it was really easy to make a small penetration into the side of the house, under the floor, not make holes into the envelope, run the line set under and into the ADU. And on the inside of the ADU, you'd have an inside wall-mounted unit, or it could go into another ducted system, which I'll show you an example in a moment. And the other thing to know is that with these mini splits, they can be set up so that you can have a separate thermostat for each of them. Now, I got to tell you that when you do set, this could be a good solution if you're doing this also as a change out for your house, because you can share the outside unit, but each indoor part of the unit, each dwelling unit would have its own separate either air handler or fan coil unit, so you're not sharing the air. But if you do that, if you do share it, even though they each have their own thermostat, you basically are set up so that when it's heating mode, both apartments or both the dwelling units are in heating mode. And then at some point it switches over. If you're up in Atascadero, for example, both units would be in cooling mode. With these simple lower cost systems, you can't heat and cool at the same time, but this could be a great solution for the mild climates and where both the dwelling units have the same kind of load profile. So what that could look like is on the outside of your house, you might have a outdoor condensing unit, and they are simple to install. This one that you were looking at on the right, that whole outdoor unit and the indoor head and all that was installed within a few hours. It was really simple. And the longest was waiting for an electrician to come out to be able to get the, to just fit the budget, fit in their schedule to add the electricity to hook that unit up. And these outdoor units can also take that line set and go to what's called a ducted or compact ducted fan coil unit. And in this case on the left, that unit was situated in the existing attic, and a return duct was now created in the hallway of the main residence, and that supply duct then in a very compact way went out and then split and then hit a couple of the rooms in the main house, and that took care of that one. And for this example on the left, for a duplex project we worked on, they did that for one unit and then they did it for the other unit, and it just shared the same outdoor unit, which was not a problem because they it was in a very mild climate, and it was mostly going to be running in heating mode throughout the year down on the coast of San Luis Obispo. Let's see. Any questions on these things? We aren't going into a lot of detail on all these options because we do have additional classes we're going to be teaching, but we do have a couple of minutes to definitely take some questions on the mini splits if there's any, if anyone is wondering about them.
Jennifer, we do have a question about the ventilation. So we can go back to that just briefly and then touch on this again. Does the Panasonic Whisper Comfort work well with supply and exhaust vents close to each other? Won't the fresh air come in and immediately be pulled back out? Do you have any experience with that?
Yes, it's the way they've set it up and the way they've kind of angled. I don't know if you can see it in that picture, the way that's angled is, yes, there is the possibility of some short circuiting, but they put a little like angle and flare on that. So I think this particular way that unit is particularly placed could have been better situated. In other words, you would want it more in the middle of the space because there's a slight angle and you're going to be blowing air. You want to blow that out one way and then pulling from the other way. And yes, there will be some loss of efficiency because of that. And with the inline fan unit, for example, you can space those a little bit more and have more control over how much fresh air is introduced. Either
Great.
way, both of these systems are preferred over an exhaust only or a supply only system, because really with an exhaust only system, if you imagine you only have a bathroom fan and maybe another fan set up, depending on how much ventilation you need, you're asking that exhaust only fan to pull air from every crack and poor construction, every place where there might have been a void or not quite air sealed around your windows or a seal around your door. You're basically asking that fan to make sure you get enough fresh air depending on how leaky, how poorly built the ADU is. So we're really looking at a better way of doing that. So even though there's a little bit of potential for short circuiting on the fresh air, overall the air quality is going to be a lot better than having your fresh air come up through the cracks and the voids in your building and potentially pulling moisture and causing mold potential in the walls. And then your indoor air quality really tanks after that. So our recommendation is do balanced ventilation.
Great. And did I hear somebody was going to unmute and ask a question? Did anybody want to do that? Feel free to. Okay. So let's see, there was one question here in the chat.
Yeah.
Is the compact duct fan coil used to heat and cool multiple rooms? Are they also called cassettes?
Okay, so this compact ducted fan coil, when it's ducted, you can send that supply duct to the bedroom and the living area and the kitchen in your ADU. You can send it to multiple places, and then you would have the one central return fan maybe centered on those 3 supply ducts. So really you'll just be limited to how much space you have to work with in terms of getting the ducts where you need them. And otherwise, if you are limited on, say, attic space or limited on building soffits within the ADUs are quite small, and same true for the main residence, then you can use these small wall-mounted fan coils, which could, phone. You could put those in multiple places if needed. So that one picture that Russ showed with that one ADU, we're pretty sure that for that garage conversion, that wasn't one of our projects, so we don't know 100% for sure, but given the size of the space, I'm guessing that they used just that one indoor wall-mounted unit, similar to the one we have pictured here, and that was enough for the whole ADU. And that's why these things are super convenient for your ADU, They even make a kit now at Home Depot. One of the brands does where you get your indoor unit and your outdoor unit and your refrigerant line set in one. You don't, it already comes pre-charged, and you have about 25 feet of line set where you can set that outdoor unit on a fiberglass pad, similar to what you see the centerpiece is actually just set on a pre-made fiberglass pad on the ground, level ground, get it down hard, you know, compact it, and get your electrician out there, and then you can run one line set up to that new unit and put that new unit right on the wall above it, and you're ready to go. And that thing installs in a couple hours, and you, depending on how handy you are or have your builder do it, you could do it for a few $1,000s, which would install. So that is a lot preferable to probably trying to bring in, you know, a forced air system, combustions, ductwork, the whole kit and caboodle. This is really straightforward.
And one thing you can do is, there's lots of names for these kinds of things, but yes, one of the names is cassettes. And so if you have a 1-bedroom ADU, so you have a bedroom and then the main building. Outside of that, you could have a cassette in the main part of the house and then have a cassette in the bedroom that could be 2 different line sets going to each of those to supply them from one exterior compressor. And so it offers a lot of flexibility, these sort of ductless systems. There's actually multiple ways you can do it, either with, you know, one cassette and then or one compact duct and have 2 ducts going into 2 different rooms. So there's lots of different ways you can set these up. That's what's so nice about these mini splits.
Oh, that's right. And each one of those outdoor condensing units, you can, like this particular one, the reason you might see a lot of those white insulated line sets coming into it is you can take and get 4 indoor units off of that one outdoor unit. And then they also have systems where they double stack those if you need it, and you can get 8 indoor units. But each one of those indoor units, like just one of those could easily handle like the 300 square foot, those ADUs, those small 300 to 400 square foot ADUs. And if you have 800 square feet and a couple bedrooms, you might want 1 in each bedroom and 1 in the main space. And it would function quite well for you. Okay, let's see. So when it comes to the hot water system for the ADUs, sometimes, well, especially for the detached standalone ADUs, you're going to have a hot water heating source for that unit. When they're already attached to the existing residence, there's a little bit of dialogue I've had with some building code officials who have said to me, practically speaking, they think each ADU and the main residence should each have their own hot water heating source. But nothing in the code precludes sharing the hot water heating appliance. Like in a multifamily situation, you can share hot water heating appliances. It's just sometimes by the time you take your existing hot water heater and you set up the whole system such that it works for both, like in a multifamily, a duplex situation, it might have just been a heck of a lot easier to just put in a new hot water heater for the ADU. So per the code, you can use a gas appliance, like an on-demand gas appliance. You got to bring in gas, new gas somewhere, and make sure that it's vented to the outdoors or it's an outdoor style unit. But if you want to save the cost of bringing gas or gas line to that new appliance, and you're looking to go all electric anyway, the code allows for electric heat pumps. And I'm not sure everyone's familiar with these appliances, so I'm going to give you a quick rundown, and also to let you know that 3C Ren is doing a lot more work on educating all of us in the field about heat pumps, water heaters. I think Sean's going to jump in a minute after this and tell us a little bit about what's coming up. But in both these examples, I chose these units based on small tank size. So this Ream example is a 40-gallon heat pump water heater. It's the one in the middle. It's got the heat pump integrated to the tank. So the heat pump's on top of the tank of hot water, and you do require an electrical connection, but no gas line has to be run to the unit at all. Now, these units do require a certain amount of volume, because when they make their hot water, they actually pull the air in through the top of the unit, the room air, and they kick out chilled air, because they've taken the heat out of the air, and through a heat exchanger, they put it into the hot, to now what's going to make hot water. And so the air that just lost its heat is now cold air. And you can install these in a closet and use a duct kit, so that cold air doesn't go into the ADU, but goes outside of the ADU. So you can duct or take air from the outdoors, pull it through the unit, and exhaust it to the outside. So 40-gallon unit, pretty straightforward. And then Sandin, and I do mention this, is we're brand agnostic, but Sandin is one of the only brands available in our area that has a split system. So in other words, you would have an outdoor compressor, just like we saw in the pictures for the space heating and cooling systems on the mini splits. Same idea. You'd have an outdoor unit heat pump doing all the work, along with its electrical connection setup. And then you'd have the insulated pipe running from this unit to the Sandin with a heat exchanger in that Sandin tank. And that tank, you could get one that's only 43 gallons. It's perfect for ADU size. And that tank goes inside, no electric needed, no noise, very quiet. You just need a small alcove or closet that would fit a tank that's about 22 inches in diameter. And if this were an ADU situation, you could get that situated right by a pretty good sized shower, and you might have your small small kitchenette right up on the back side of that wall to the shower and the tank, and you have your hot water right where you need it. So your install costs would be reduced in that sense, because you're not running gas and your plumbing lines are really short. So that kind of segue, unless there's some questions on that, it really kind of, let me mention, so there's the install costs a little bit that I briefly mentioned, and sort of choosing your fuel based on what you have on your existing site and what is appropriate. The cost implications of operating these. So the cost of electricity in our Tri-County region and the cost of gas in our region is now making it that these heat pump water heaters and your gas unit are running almost neck and neck for operating costs. When I say neck and neck, maybe you would spend a little more on the heat pumps right now based on the water draw, based on the cost of electricity, and based on where gas is currently. But when I say a little more, I'm talking like maybe some of the analysis that have been done is like putting it at $20 more, $30 more for the year. So I'm really, really close. Most people would not notice the difference in that. And then as the price of gas continues to go up, and as we get more and more renewables on our energy grid and the cost of electricity is leveled out, that small difference is probably going to flip or at least be neutral. Okay, so that kind of segues into a path for all electric ADUs. And in our practice, we're seeing a lot of all electric ADUs because a lot of folks are not wanting to run gas to their ADU for cooking. So they're putting either electric cooking or induction cooktops. There's clothes dryers that can be either run with heat pump technology or old school electric resistance. You eliminate the combustion issues in the ADU, and you don't have to worry so much about monitoring your ADU for carbon monoxide. And you've got options now with those mini splits and a couple of options for heating your hot water with the Sandin or Rheem or A.O. Smith, and there's a couple other brands that are available in our area. Oh, this diagram here on the left, for that question about what do the indoor units look like and are they called cassettes? This one on the left shows you that you can take that outdoor unit and actually send a line set to a recessed ceiling unit. You can send it up to the ducted fan coil that we showed you in a picture of, and just under that is the wall mounted unit, a high wall mounted unit, and then they even have a floor mounted unit down below. So there's some options within several brands that are available in our area. And a lot of our clients, we are finding that they're in general asking about all electric, and they often want to know how they can reduce their carbon footprint and how can they make their new building greener. And given the current mix of energy resources on the California grid, the California Energy Commission has determined that going all electric compared to a mixed fuel compliant home is going to reduce your CO footprint by going all electric and using the PVs and using the heat pump technology. So with that, any more questions before we get into a little bit on the PV sizing?
No, I think that's good. Does anybody have a question they want to unmute and ask?
I have a quick question. So in this, can you so a single condenser, a single outdoor unit will service your water heater and your air heating, correct? It would be a single unit inside, correct?
No, not on the ones that I showed a picture of. No, unfortunately, they are available. They're available in Europe and Brazil and just about everywhere else. But for whatever reason, in California, at least a couple of companies that were offering to do both water and space have pulled off the market, and they're not back on the market. They're not offering their product. So right now you would buy one system for space heating and cooling and another system for your hot water. So in effect, you would unfortunately end up with two outdoor condensing units for our situation in California right now. Yeah, I don't ask me why. It's detail, it's nuanced and frustrating for those of us who are into this sort of thing. But right now the manufacturers are not offering those products in California.
But if you wanted to just, if you're just heating, you could use the Sandin to provide domestic hot water and a fan coil for heating?
There's a way to do it. There is a way to do it. You'd work directly with them and ask them more questions about it. But yeah, if you want to just go with like off the shelf sort of technology, then you might do one of the kits. It just depends on your budget and how much of this you're doing yourself and where your builder buys their things, because they might just go and get a ream from Home Depot and one of those kits for the one-to-one outdoor unit, indoor unit, you know, also from Home Depot, big box store. I mean, that's a possibility. That's affordable. That's available right now in California, in our Tri-County area. Now, if you are doing new construction, or your client wants to have more energy independence and they're thinking of how they want to purchase their power and they are interested in photovoltaics, the California Energy Commission, part of the code now, does have a prescriptive kind of PV sizing equation you can use. And this would meet usually anywhere between 40 to 60% of the electric energy needs if you use this equation. And it's a broad kind of a range because so much of our electricity need in our homes has a lot to do with how much other stuff we plug in. It has a lot to do with all our gadgets and our habits. But in general, 40 to 60% of your electricity for your project could be met through a PV system using the sizing method. So the code says if it's a standalone ADU, you can use this prescriptive sizing formula based on conditioned floor area times a factor based on your climate zone, plus the number of dwelling units times another factor for the climate zone. So let's say you were building a brand new 600 square foot ADU on your property. You could use the equation and take that 600 square feet times a factor, say for climate zone 4, 0.586, divide by 1,000 plus, you've got one bedroom, so you're just going to add the 1.21 to it, and you end up with 1.56 kilowatt DC system size. And it's just a nominal sizing. So if you knew that you were going to get a panel, a residential scale panel, and they usually come about 40 inches, sometimes a little narrower by 67 inches, sometimes a little shorter, but roughly that size, you can take that 1.65 kilowatts and divide it by your 340 watt panel. Essentially, you get a fraction of a number, you could round it up, and 5 panels is what you would need for that 600 square foot ADU to meet that requirement. Now, if your ADU is in a lot of shade, you might qualify for an exemption. Or if that ADU doesn't allow for 80 square feet of contiguous space, you might not have to do the PV panels, or you might take that quantity of PV panel and add it to the main house instead, and you can add more panels to that as well for the main house, as long as that system is permitted with your ADU. And for those of you on the call who have to deal with looking at those Title 24 reports or checking out, there's a little sidebar here on the energy modeling. If you're going the performance method route, you are doing a brand new project and it includes an ADU on right off the bat on the project. You can model that main house and your ADU as a separate zone, and the software is going to ask you if, in the general part of it, it's going to ask you if it's an accessory dwelling unit. Yes, no, and if it's attached or detached. And that will show up on your report for that project. Now, if you have a new ADU that is being permitted by itself, standalone, you can still choose it's a detached ADU on that unit. But I got to point out that it won't show up on your report. It'll just show up as a single family house on the cover sheet. And I point this out if there's any plan examiners on the call too, because we get this as a question. Hey, it's an ADU. Why doesn't it say ADU on the Title 24? Well, if it's detached, standalone, it's, as far as the energy code's concerned, it's a single family house, new construction, and it shows up that way on the report, not as an ADU. And lastly, I want to point out this great resource, blueprint. For those of you who have to really follow the code and kind of keep up on all this, they have, it's a wealth of information. And this particular issue does go in more deeply to the PV requirements on those ADUs, which, you know, it's going to show up as single family on your Title 24 report. You run it by itself, but it kind of goes through what the PV requirements are. And it explains a little bit more about the exemption. So if you, in other words, if you have less than 80 square feet contiguous feet roof area and it's shaded, you might not have to do the PVs. And it also, for the folks working behind the counter, and if you're not familiar with all this, I think it helps really just point out that all the additions and alterations to an existing home do not require the PVs. So it's really only the brand new construction. And the PV requirement does not apply to the mobile home ADUs, or those all would fall under Title 25 and not Title 24. Okay, we have, it's 10:15, and we have time for questions and more discussion. And Russ and I are going to kind of sum this up for you guys, but also we would love for you to ask us any questions. Let's see.
We've got one question here, Jennifer. Does electric resistant heat, are they options instead of heat pumps or ductless or ducted for space conditioning? Is electric resistance allowed under the current code cycle?
Electric resistance heating is allowed under the current code cycle for performance energy modeling method only. So prescriptively, if you wanted to build your ADU and follow like that recipe card, the prescriptive recipes that we've been laying out, and not do detailed energy modeling, then no, you would just put in the mini split heat pump and be done. But if you want electric resistance, you can hire an energy consultant to do an energy model for you. And under that modeling system, you're going to be compared to a project that does not use electric resistance heating. And so in order to get that electric resistance heating into your project, you will probably have to do other things in that ADU to bring up the overall, efficiency, to bring that up to baseline essentially, which means you might end up doing really, really good windows, and which might be like triple pinged, and you might be adding more exterior rigid insulation than just the R5. And because on an ADU, it's so small of a project. On the one hand, typically they're so small, you think, oh, why not electric resistance heating? But also because they're so small, they actually don't have a lot of surface area to work with. So you have to increase the efficiency of that envelope even more to kind of offset some of that on the electric resistance.
So there's trade-offs, right?
Yeah,
So
there's
you have
trade-offs.
to,
And,
yeah.
and the heat pump won't give you much trade-off just because of the size of the unit. And but it can give you quite a bit. It just depends. I've seen it where almost all the energy efficiency savings we needed came from using a new heat pump water heater for the project, which then allowed for cadets electric resistance cadet heating. And I usually see that for climate zone 6 and 7. So Santa Barbara area. I haven't seen it for up here where I am in Atascadero. That it just doesn't work up here, but it works a lot down in Santa Barbara.
Great, wonderful. So the other question is it really about radiant floor in a detached ADU? Is it economical? Is it practical? What is your experience?
Radiant floor heating is nice and comfortable for a lot of people who spend time on their floor. And I think it depends on your age and comfort. Really young folks that are on the floor a lot, it's great and comfortable. Me personally, now I wish I had radiant floor as my, now I'm getting cold feet. Never, okay, I didn't have cold feet until just starting this year. So now I'm like, ooh, radiant floor, wouldn't that be so nice? So, okay, so there's reasons you're gonna wanna do radiant floor for comfort in certain situations, but it's not gonna be the most cost-effective way to deliver your heat. If you're in, the operating costs and first initial costs, it's not even going to compare to the mini split.
Okay, and that also in slow, so that it was similar. Like you think it being located in slow is not going to make much of a difference.
Right. So, and then the other thing, and then situations. So, like, let's just say you've got a small bathroom, or just a real small bathroom and kitchenette, and maybe the ADU is for somebody who is older. It's possible that you could put an electric mat meant for that purpose in that shower or a part of it that's right in front of the sink. And you can put that on a timer, and you can insulate it from the ground if you're on a slab, or you can also, use it in a raised floor application, and they make it, but you'd have to do a little gymnastics, make sure the floors are level, and then put tile over it. But if that's an issue where you really need it, you can do that. Or even less expensively is you can put these small electric heaters in the kick space of a cabinet that can also be on a timer or on a wall switch. And you can turn that thing on, and it's super easy to install. They make it to fit within the kick space of a cabinet, and you replace the toe kick with a grill that they have, and it just blows warm air right onto a person's feet, and they could stand on a pad instead of tile, which also kind of goes with, being able to, you don't want a trip hazard, but you could make the floor more soft and easier to stand on and have warm air at the feet. And that would be a lot more cost effective than doing a whole radiant floor system.
Yeah, and too bad Steve Mann was on earlier, and I believe he designed a passive ADU, passive house ADU, and I think he used radiant heating, but yeah, it would be nice, be great if he was still on. He could tell us that what his
Right? Tell us a
experience
little
is.
bit more about the costs.
Yeah, and comfort and you know how that worked. I just
Yeah,
I can't quite remember whether it was radiant floor or not. I know it was a passive house though, so that would
yeah. The
certainly
last
help.
project I worked on, we were looking at doing radiant floor heating for about 12,000 square feet of the house. And the cost for just that was like upwards of 30,000. And again, it's a comfort. It comes down to how much money you want to spend. But the mini splits for that same size house installed cost was less than 15,000.
Okay, I know that was a 1,200 square foot.
Yeah.
Okay,
Yeah.
yeah. I think insulating that slab is really key to those success. I know that
Right, whether you put radiant heating in the slab or not. It's now putting the extra money and doing a full under slab insulation and a really good like Stego. That is one time I do stick with the brand Stego under the slab for moisture control, because that combination of stopping all moisture and vapor migration and the insulation makes your slab much more comfortable to be on.
yeah, no, I built a home that had radiant slab, and I think that was the thing that we should have done, is added a lot more insulation.
Right. I grew up in a house not too far away from you with radiant floor heating. And in the wintertime, it was great. It was really great. So I think in a way you can't beat it, but I wouldn't be doing it because that's the way you're going to save energy, and you got to look at the size of your heating system to heat the water for that. And right now, your best options, if you want to go heat pump, like an AirMac brand, if you're really considering it, look up AirMac. Those are heat pumps that are meant for providing enough hot water for radiant floor.